Hi everyone, my name is Juan Carlos Camacho and I'm going to teach you how to solve 9 problems of Model 2 of Matter and Energy 2. In the first exercise, there is frequency equals to 1 Hz. That means the period is equals to 1 over frequency. The period is equal to 1 over 1. That means the period equals to 1. In the second problem, we have frequency that is equals to 300 Hz, amplitude that is equals to 2.2 millimeters, that is the same that 0.0022 meters, and distance that is 0.001 meter. With the formula, we have to look for clear for velocity. Velocity is equal to 2 pi times frequency times amplitude. Velocity is going to be equal to 2 pi times 300 times 0.0022. Velocity is equal to 4.14 meters over second. In this third exercise, we are looking for potential energy and for work. And for that, we have to clear first for force. Force is equal to minus KO times distance. Distance is equal to 0.035 meters and K equals 280 newtons. First, we have to use this formula, minus 180 times 0.035, and it's equals to minus 6.65 newtons. This equals to force. Then we have to use this formula, force times distance, to solve for work, and work it's gonna be equal to minus 0.23 newtons. And that's because we multiplied minus 6.65 times 0.035. And the last one, the potential energy. Potential energy's formula says that 1/2 of K times displacement to the square, it's equals to potential energy. And potential energy equals to half of minus 180 times 0.0035 to the square. Potential energy equals to 0.160 joules. In the fourth exercise, they are giving us the force that is equals to 100 newtons, the mass that is equals to half kilogram, and the length that is equals to half meter. And they're asking us for the velocity. First, we have to solve for mu. Mu is equals to mass over length. That is 0.5 over 0.5 equals to 1. Well, now we use this formula. Velocity, that is what they are asking us, is equal to root of force over mu. Velocity is equals to root of 100 over 1. That means that velocity equals to 10 meters over second. In the fifth trouble, they are asking us for the mass. We have length that is equal to 4 meters and force that is equal to 300 newtons. Then we have also velocity. Velocity is equal to 150 meters over second. First, you have to clear for mu. Mu is equal to force over velocity to the square. Mu is equal to 200 over 150 to the square. That is equal to 0.013. Then we use this formula. Mu equals to mass over length to clear for mass, and mass equals to mu times length. Mass is equals to 0.013 times 4, and mass is equals to 0.033 kilograms. In the sixth problem, we have time, the length, the density, and the intensity. Intensity is equals to 1.17 times 10 to the 11. Density is equals to 8,800 kilograms over meter cubic. Length is equal to 2.5 meters, and time, it's what they are asking us for. First, we have to solve for velocity. Velocity, it's going to be equals to intensity over density in the root of that. That's going to be equal to 1.70 times 10 to the 11 over 8,800. Density, velocity, it's going to be equal to 3,646.29 meters per second. Then we use this formula. Velocity equals to length over time. That it's going to be clear for time. Time equals, it's going to be equals to length over velocity, and time it's going to be equal to 2.5 over 3646.29. And time it's going to be equals to 6.85 times 10 to the minus 4 seconds. In the seventh problem, they are giving us a dp that is equal to 55 dm. Then next is the intensity, the minimum intensity, that is going to be equals to 1 times 10 to the minus 12 W over meter square. So there exists this formula. V equals to 10 logarithm of intensity over intensity 1, and that you have to clear for intensity. So intensity it's going to be equals to intensity 1 times logarithm 10, like times 10 to the v over 10. And substituting the values, it's going to be intensity equals to 1 times 10 to the minus 12 times 10 to the 55 over 10. And the intensity is going to be 3.16 times 10 to the minus 7 W over meter square. In the eighth problem, they are giving us first the frequency of the object sound, that is 560 Hertz, the velocity of the object, that is going to be 60.6 meters over second, the velocity of the sound, that is going to be 343 meters over second. And we have to use this formula for solving for the frequency that you can hear. The equation says that the frequency is equal to frequency 1 times velocity of the sound over velocity of the sound minus the velocity of the object. Then we have to use this. Frequency equals to 560 times 343 over 343 plus 60.6, and frequency it's gonna be equals to frequency is gonna be equals to 560 times 343 over 343 minus 16.6, and those are the highest value we can hear and the lowest value we can hear. That it's gonna be 588.68 Hertz and 534.05 Hertz. The ninth one, we have velocity that it's gonna be 20 meters over second. The frequency of the sound, that it's the frequency of the object, that's gonna be 330 Hertz. The frequency that they are asking us, and the velocity of the sound. The velocity of the sound is gonna be 343 meters over second. Then the same formula than the last exercise, that it's going to be frequency equals to frequency 1 times velocity of sound over velocity of sound minus the velocity of the object. Then we have these formulas and we substitute frequency and frequency. Frequency 1 for the major, it's going to be 330 times 343 over 343 plus 20. That is going to be 311.8 Hertz. And in the minimum, that's going to be 330 times 343. That is going to be over 303 minus 20. That's going to be 350.3 Hertz.